Good morning, students. Today we are going to see the topic of isomerism in complexes. What is meant by isomers? The coordination compound which have same molecular formula but have their ligand attached to the central metal atoms in a different ways are called as isomers. These isomers have different properties. Your isomers or the phenomena of isomerism is basically broadly classified into two categories. One is structural isomerism and second one is stereo isomerism. Your structural isomerism phenomena is again then subdivided into 6 types. First type is ionization isomerism, second is hydrate isomerism, third one is coordination isomerism, fourth one is linkage isomerism, fifth one is polymerization isomerism, sixth one is coordination position isomerism. Your stereoisomerism is further subdivided into two categories. First is geometrical isomerism, second one is optical isomerism. Now we are going to see in a detail what is the structural isomerism. When the coordination compounds have same molecular formula but have different structures, then they are known as structural isomers and the phenomena is known as structural isomerism. First of all, we are going to see ionization isomerism, which is the first type of structural isomerism. These isomers have same molecular formula and are different due to the position of ligand or groups within or outside the coordination sphere. These isomers give different ions in their solution. It is important. Your ionization isomers give different ions in their solution. Just see this compound or complex CONH3 by 5 BrSO4 have following two isomers. So just see this molecular formula of this compound and this compound is same, but their structural formula are different. So in this formula we are clear cut see that it has sulfate ion as a counter ion, but in this formula we see that sulfate ion comes in a coordination sphere and bromine ion goes out the coordination sphere, and in this formula basically your bromine atom or ion acts as a counter ion. So when the solution of this complex is treated with barium chloride, so we see that in this complex sulfate ion is a counter ion. That's why it is reacted with sulfate ion and precipitate of barium sulfate is obtained. But when we treated solution of this complex with AgNO3, there is no reaction because AgNO3 solution reacted with halides. So now when this isomer of your complex is reacted with barium chloride, so in this complex we see that bromine is counter ion, so there is no reaction taking place. But when we reacted this solution of this complex with AgNO3, then precipitate of silver bromide is obtained, which is yellow in color. Some other examples of ionizable isomers are written here. So just see in this pair, in this complex, NO2 is present outside your coordination sphere. It is the counter ion in this case. But in this complex compound, we see that NO2 comes in coordination sphere while one of the chlorine atom goes outside the coordination sphere. So both these complexes are ionizable isomer of each other. When this complexes is treated with silver nitrate solution, so this complex does not react with silver nitrate, but this complex give precipitate of AgCl because one chlorine atom present outside the ionization. One chlorine atom is present as a counter ion. In this case, we see that bromine is counter ion, while in this case your bromine comes inside the ionized coordination sphere and one of the iodine goes outside your coordination sphere. That's why these two complexes are ionizable isomer of each other. So now we are going to see hydrate isomerism. Hydrate isomerism is similar to your ionization isomerism, in which the water molecule, it is important, in which the water molecule acting as a ligand and are replaced by the anions present outside the coordination sphere. Just see the example of complex CrCl3 6H2O. This complex have 3 hydrate isomers which are written in this tabular form. Just see in first hydrate isomer, all water molecules are present inside the coordination sphere while 3 chlorine atom acts as a counter ion. This complex have violet color. When it is treated with concentrated H2SO4, it does not lose water molecule because water molecule, it is the part of coordination sphere. But when it is treated with silver nitrate solution, 3AgCl is precipitated. The second isomer, hydrate isomer of this compound is written like this. In this case, we clear cut see that one of the water molecule goes out of your coordination sphere while one chlorine enters in a coordination sphere. Color of this complex is green. When it is treated with H2SO4, basically one water molecule lose by this complex which are present outside your coordination sphere. So this water molecule is actually loses when it is treated with concentrated H2SO4. When this complex is treated with silver nitrate solution, 2 molecule of AgCl is precipitated because 2 chlorine atom is also acts as a counter ion in this case. So in the third isomer of this complex is written here. Just see in this complex 2 water molecule goes outside of your coordination sphere while 2 chlorine atom come inside your coordination sphere. In this color of this complex is blue green. When it is treated with concentrated H2SO4, it basically loses these 2 water molecules which are present outside your coordination sphere. When this compound is treated with NO3 solution, one molecule of AgCl is precipitate. These are some other examples of your water hydrate isomers. So in this case, just see that water molecule present inside your coordination sphere and 2 chlorine atom acts as a counter ion, while in this case that water molecule goes outside the coordination sphere, one chlorine atom come inside your coordination sphere. So third type of isomerism, it is known as coordination isomerism. This type of isomerism is shown by those complexes which are composed of complex cation and complex anion. Coordination isomerism are obtained when some or all ligands of both the coordination sphere are interchanged with each other. In this pair of central metal atoms may be same or different. For example, just see, this is the example of polynuclear complex. In this complex, there are two metal atoms are present. First is cobalt, second one is chromium. So in this case, we clear cut see that your cobalt is attached with 6 amine ligand, while your chromium is attached with 6 cyanide ligand. Now just see this complex. In this complex, we simply see that cobalt is attached with 6 cyanide ligand, while chromium is attached with 6 amine ligand. So simply the interchange of ligand taking place in these complexes, and that's why they are known as coordination isomers, and phenomena is known as coordination isomerism. Next type of isomerism is ligand isomerism. This isomerism is shown by those complex compounds which have ambidentate ligand. It is important. For example, NO2 minus, HCl minus, etc. These ligands can coordinate with central metal atom through any one of the two different available donor atoms, thus giving two donor atoms giving two different compounds which are known as linkage isomers. So now we are going to see the example of linkage isomers. So just see, in this compound, name of this compound is pentamine nitro cobalt. So what this nitro says, this tells us this cobalt is joined with your this nitro group through nitrogen atom. It simply means that nitrogen attached to your central metal atom through coordinate bond. Now just see the structural formula of this compound. In this compound, we see that this is the basically nitro group, but it is written as ONO. It simply means that in this case your central metal atom cobalt is joined to nitro group through oxygen. The name of this compound is pentamine nitrito cobalt. So these two are basically example of linkage isomers. They are linkage isomers of each other because in this compound nitro group join through nitrogen, while in this compound nitro group joins through oxygen to your central metal atom. Just see second example. In this example, your thiocyanato group is basically attached through sulfur atom with chromium. So that's why name of this compound is hexathiocyanato S-chromate 3. While in this case we see that central metal atom join through nitrogen, or nitrogen is joined to your central metal atom. So name of this compound is hexathiocyanato N-chromate 3. Now we are going to see polymerization isomerism. When one complex is a multiple of other complex in stoichiometry, they are said to be polymerization isomers of each other. All these isomers have same ratio of metal atom and ligand. So just see these two complexes. In these complexes, if we calculate ratio of metal to ligand, it is come as 1:2:2. While in this complex, if we calculate ratio of metal to ligand, so there is 2 chromium atom. So that's why 2, 4 your amine ligand, so 4 is here, and 4 is your chloro ligand, that's why 4. So it is basically 2:4:1, that is 1:1:2:2. So they are example of your polymerization isomerism. They are polymer isomers of polymer isomers. Next type is coordination position isomerism. This type of isomerism is shown by those complex compound which contain bridging ligand. It is the important condition and arises when non-bridging ligands are differently placed around the central metal atoms. So just see in this example, this OH acts as a bridging ligand between these two cobalt atoms. Now we are going to see the condition. In this case, we see that left hand side cobalt atom is attached to 4 amine ligand, while right hand side of cobalt atom attached to 2 amine ligand and 2 chlorine ligand. Now just see this compound. In this compound, we clear cut see that your left hand side of cobalt is attached through 3 amine ligand and 1 chlorine ligand, and right hand side of cobalt is also attached to 3 chlorine ligand and 3 amine ligand and 1 chlorine ligand. So basically in these two compound, molecular formula are same but structural formulas are different. And why that structural formula is different? Because in second case we see symmetrical arrangement of your ligands on both cobalt, while in this case we see there is unsymmetrical arrangement of ligands on your cobalt metal atom. And this type of isomerism is known as coordination position isomerism. In our next class, we are going to see stereo isomerism. Thank you very much.